red light on? Well, I'd like to thank everybody for coming tonight. I guess, as Nimrod said, I'm a little bit voice impaired today, so I'll try and see how long I can hold out. But again, thanks for coming. Do we have people here that have looked at Clojure or actually used Clojure for anything? A couple of people, or maybe more broadly, Lisp people that are excellent. So you people are going to have to keep me honest here. I'm not much of a Lisp person. I don't. At least I don't call myself that. I've dabbled in Scheme, a few years back, and I've started looking at Clojure probably since summertime. But so I'm an interested observer. I'm in no way an expert here, So I will answer whatever questions I can, but I can't promise anything. My main goal here, in addition to being able to have a voice at the end of this, is to get you interested enough to look at these two URLs here and maybe examine further, because I think it's worth a look, and it's certainly been worth a look for me in the last few months, and I'd like to think that even if you don't end up using Clojure in your everyday life, it's still probably a useful thing for you to at least look at and learn from. It's certainly different than what you might have done with Java. So I have to start out with the obligatory XKCD comment, because that's what everybody does these days, and all the Clojure presentations I've seen start with either this one or another one, so I had to include it. So Clojure is a Lisp, which means it has all of the parentheses that you are accustomed to with those particular types, dialects of language. For me, it's, you can divide developers into two people that can get past the parentheses and people who can't. I can't really help you if you're in the latter group. All I can say is give it a try and see how it goes. From what I've heard, after a while the parentheses disappear. You don't see them anymore, and at that point you know you're a Lisp person. So what is Clojure? Clojure was sort of a vanity project by a man named Rich Hickey. Started it several years ago. I think he worked on it for something like 2 years before he even brought it out into the wild. It is a hosted language, which means it lives on a virtual machine. He developed it against the JVM, but there is also a .NET implementation, which is a little hard. From what I understand right now, it's a little hard to get running, but it does actually work, and people are using it. The 1.0 release of Clojure came out just about a year ago. I think it was a year ago in October, and the 1.1 release came out just at the end of last year, so had a lot of new stuff. And I think the 1.2 release, I don't have any special knowledge here, but it seems like that's probably not too far away. The coding and the people that are doing the coding on it seem to be pretty excited about the new features they're working on. So that leads me to believe that they're likely to come out with the next release fairly soon. Now, one of the things that I discovered in rehearsing this presentation is that it's really hard to do justice to this language in the amount of time that I have available. So what I'm going to try and do is, I want to get to the stuff at the end, so what I'm going to try and do, and I've tried to arrange it so that I'm going to give you the very basic stuff right up front and very quickly, hopefully I don't get bogged down. Now I sort of prefer an approach of showing you the stuff directly rather than throwing slides up there. So you may have to put up with my bad typing or my nervous typing at this point, but hopefully that will go fine. The examples that I show at the beginning, I'm going to try and run through them fairly quickly so I can introduce you to the concepts here. And then I've tried to choose some demonstrations that illustrate these things a little bit more, so that try to have several different things going on at once so that you can pick up the concepts. But again, I'm not going to cover everything by any stretch. And again, I hope that you will be interested enough to go and check out other things after you leave here and down the road. So again, Clojure is a JVM-based Lisp dialect. It consists of a couple of jar files. There's a Clojure.jar file and then a Clojure-contrib.jar. And the Clojure.jar is where all the core functions are. It's not actually that big. It's less than a megabyte, I think, in size. And it's the core functions can get you pretty much anything you need. The Clojure-contrib is considered all the extra stuff that may or may not eventually get moved into core, but it's sort of like the testing ground for new stuff. So if you're developing new stuff for Clojure, then you would probably submit it to Clojure-contrib. It's an open source sort of arrangement. I think you have to send a written statement that says that you give the rights to the code to Rich Hickey or whatever, something like that. And, but at that point, he's pretty good about just committing stuff if he thinks it's good. So he's a pretty neat guy, actually. I'd encourage you to go look. He's got a lot of videos online. Very interesting person. So Clojure-contrib, will have a lot of really interesting things, but a lot of real crap in there too. So you have to sort of wade through it. But the core really does contain a lot of stuff, and it's going to be, for pretty much everything you need is going to be in the core. So both of the code bases are based in GitHub, which seems like everything is based there now. And you can also get it out of the Maven repository if you so desire. There's a couple of different, you can use Maven to do your builds in Clojure, and there's also a Clojure-based sort of DSL that just wraps on top of Maven now, which is called Lanigan, and that's I haven't actually looked at that too much, but it looks fairly promising. So IDE support. There's you want to use a text editor, right? What else would you use? No, the main IDEs that you're going to use all have at least some level of IDE support at this point. NetBeans, I think, is probably the most mature. I hear the most on the web list, on the mail list and stuff. There's most of the traffic gets talked about in Clojure, which is the NetBeans version. I'm a NetBeans person myself, so that's the one that I have used. I don't actually use in Clojure either, but that's the one that I would use if I was using NetBeans for Clojure development. Eclipse also has another one that I don't really hear a lot about, but it's available, and so I literally know nothing about the Eclipse. I don't even use Eclipse, so I can't say anything about it. VI also has apparently a very good one. I don't use VI in my development, so but people really seem to like the VI version too. The one that everybody seems to use a lot is Emacs, though, as you might expect, because Emacs is a Lisp-based application. So it really, Clojure is a good fit for it. It already does Lisp. It already does all the formatting, and it's got the infrastructure in place. It has what's called a SLIME implementation. SLIME stands for Superior Lisp Interaction Mode for Emacs. And so I can, it took me a little while to figure out how to set it up. I'm not much of an Emacs user either. So it took me a little while to figure it out, but you can it's not too bad to get up, and there's good instructions on how to do it as well. So the stuff that I'm going to show you now is going to be all in Emacs. Now I should mention also that if you're on Windows, there's a product or a package, I guess, called Clojure-box, which is pretty nice. I mean, it's just a Windows installer, an exe file. You go and you download it and you double click it, and it will install an Emacs on your machine and set it up for you with the whole SLIME implementation, and so give you a little icon on your desktop and everything, so you can just double click and get right into a Clojure REPL. So that's pretty nice, and I tried that on a, not on, actually on a virtual machine on this box. I'm running Linux here, but the Windows thing installed very quickly, and I was right up and running in minutes. So it's pretty nice. If you're on Windows, you should check that out. Let me go ahead and switch over here. So Clojure is, like I said, a jar file, and let me just locate it. So I've got several on here, but and so I have, and there are various bash scripts around, sort of like that you can use to run from a command line itself. And I have one on my bin path here that, ooh, it's kind of hard to see when it wraps like that. So all I'm doing is running a Java command, right? I've got a couple of parameters there, and then I'm setting a class path to a particular directory where I put Clojure stuff in, or any kind of Java jars that I want to include on the class path. This is very straightforward Java calling stuff. I'm also calling a library called JLine, which lets me do command history and that sort of stuff. And then it calls the Clojure.main class. And when I do that, I'm going to just backtick escape it here to actually run that. And what it does is it brings up this thing called a REPL, R-E-P-L. That stands for read, eval, print. Wait, read, eval, print, and loop, right? Thank you. So every command that I type into the REPL gets read and then evaluated, and then it loops around and gives me another thing. Now what you see in this command prompt is the name of the namespace that I'm currently in. So by default, you get put into the user namespace. So in the user namespace, we'll by default pull down all of the Clojure.core code, all the functions that are available in Clojure.core, the main Clojure.core, and then also the Java .lang, everything that you get in Java for free that you also get into the REPL here. So and this is, now I'm running just from a bash prompt. I'm going to switch over here to Emacs. So here I'm in Emacs, and to run Slime, I just type meta-x and then Slime, and then what it will do is it will kick off all this Slime stuff, and then I'm in the same exact place. So I'm now at a REPL inside of Emacs, and the nice thing about this REPL is it's all very Lisp aware, and I can just type parentheses out, and it will keep track of my parentheses, and it will indent things properly and all that sort of thing. So very nice environment to work in if you're familiar with Lisp. So let me just run through a couple of different the primitive things inside of Clojure are very similar to what you'd see in a Lisp. And let me just run through this. So I've already shown you one. Numbers are all primitive symbols, and that includes things like rational numbers, exponents. It also does things, ratios. So if I do 9 divided by 5, it will store it as 9 divided by 5. Or 18 divided by 10, it will also reduce that. So the eval reduces it to its lowest terms. Strings, of course, are also symbols. And each one of these things, as I'm hitting enter, I'm evaluating it. So you see that these primitives all evaluate to themselves. Characters are another thing that you can see. They are backslash delimited. So each, and these are just regular Java characters. Booleans, of course, are both available. The nil is the equivalent of null in Java. Now Clojure also introduces another thing called the keyword. So anything that starts with a colon is a keyword which evaluates to itself. And keywords can be any kind of other symbol, and they are often used for things like keys to maps and that sort of thing. They're very convenient to use for that sort of thing. And there are also some other primitives that are available. There's this form when I do a hash and then a quoted string is actually a regular expression. So regular expressions are a first level thing inside of Clojure, and I can evaluate these things against strings using functions. Now, of course, since it's a Lisp, the primitive, it has a primitive that is a list, and lists are all evaluated, delimited by parentheses, and a list gets evaluated as follows. So let me just do this. The first item in the list is a function that's going to be called, and everything else after that are the arguments to that function. So if I do class string, then it's going to run the class function against the argument string. And you'll see that what I retrieve, everybody can see this, right?
Mm-hmm. Is it possible to clear the screen up to the top? There we go.
I can do this. So what I've just produced here is a Java string that has all of the rights and responsibilities of a string. And in addition, integers are java.lang.integer, and then all the other things that, like I showed before. The keyword is a Clojure keyword. Again, so now some people are. Another thing they should notice about the Slime environment here is when I type a function like plus, which is a function name, at the bottom you can see I have a thing that shows me what the parameters are available for that function. So class, for instance, showed me that takes an x, which is really useful. But I know that plus will take either no arguments, one argument, two arguments, or two arguments plus more. So I can say 1 plus 2. That's how I write 1 plus 2 in a Lisp or in Clojure, which can be a little off-putting if you're not used to that sort of this prefix notation is what they call it. But the nice thing about it is that I can include multiple things without having to type the plus in a bunch of times. So there are trade-offs there. And each one now, again, a difference that here that with another language like Java is that plus sign is not a keyword. It's not an operator. It's a function. It's being called. It has been defined within Clojure.core to do the sort of things that you expect it to do, but it is not a keyword in the language. In fact, there are almost no keywords in the language at all. It's all built from these primitive operations, or primitive forms, I guess they call them. Now, another one of the things that Clojure introduces, what I've shown you pretty much so far would not be unfamiliar to anybody that's just a Lisp user, a common Lisp or scheme sort of user. I haven't really showed much that's different, other than the fact that these are Java classes. But one of the things that Clojure does introduce are different types of collections. So, for instance, we already saw the regular list, which is evaluated. There's also this. Let me just go ahead and define this. So what I've just done now is I've defined a variable, or a symbol, actually is what we would call it here, called v, and I've assigned it to this square bracketed 1, 2, 3 thing. And what it returned there is the namespace qualified version of that. So what it's saying is that it's in the user namespace / the name of the variable is v. So I can type in v and it will return the thing that I just entered. Now, what is that thing, you ask? It is a Clojure persistent vector. So one of the things that Clojure's introduced, in addition to lists, are vectors, which are denoted by square brackets. And these things can be, they don't have to just contain a single type, they can contain anything. Right, so that's a valid vector in Clojure. Another kind of collection that is introduced is So what you see there is, as you might guess, this is a set. It's because I just added a bunch of things that were the same, and it has cleared out any examples that were duplicates. So this is a set. Let me just define one of those. So now I have this set that contains only the unique items with it that I just typed in.
That's the hash curly brace does that?
Yeah. So that is the format for a set. So I do you can see it's a persistent hash set from Clojure. The other one, which is guess what that is?
Persistent map.
Indeed.
What's the persistent mean?
I'll
It
get
tries
to that.
really hard, or
Good question. So one thing before I get to that question, let me just point out that the REPL response, the evaluated version of that map, is contains commas. You see how it has the one, and then comma. In Clojure, commas are white space, so I can put the commas in if I want. I can leave them out. I could put nothing in, and it would treat it all the same. And that's true of any of these collections that you see here. Commas can be put in just for readability if you want.
Stan, I don't remember my lisp or scheme well enough to know like where we're varying from other versions. Not that you have to point out every one, but it might be helpful to know like is this thing with maps? At least this is like tactic sugars that they're at.
Well, I'm not much of a list person either, but I think from what I understand, this map, these sort of things are all introduced in Clojure. That may not be true. There may be lists that do this too, but someone will correct me if I'm wrong.
association.
I mean, I remember doing lists
Yeah.
of lists.
Right.
And so I imagine we were kind of making our own maps, but
Right. Yeah. I mean, I think one of the things about these different formats for these collections is that since they use different delineators or delimiters, that makes the code a little bit easier to read in many cases, which is always an issue in Clojure or in lists, I think, for people until they're good, right? And then things disappear. But does that answer your question?
I think so, yeah.
So again, the excellent question that was asked was, why is this called a persistent array map, and why is it a persistent hash set, persistent vector, and these things? The answer to that is that every one of these collections that you see is a immutable thing, right? Rich Hickey uses the term fully persistent. Which means a little bit different from what I'm used to hearing. When I think of persistent, I think of being stored on an I/O device somewhere. But in the computer science terms of apparently there's a term for fully persistent, which means that the value resides in memory for as long as from the time it's created until the machine runs down or something like that. So my M that I created there is always going to be these 3 entries. Now you may ask, well, how do I change an entry, or how do I add an entry to this map if it's always going to be the same? And the answer is you don't. You say, I'm going to associate assoc is a function that adds an entry to a map. So you can see the assoc takes a map, a key, and a value. So I'm going to add this key 4 with the value 4 to this map. What happens is I've returned now a map with 4 items in it, but M is still going to be the same. It's still got 3. So if I want that to be assigned to a variable, I have to def a new one. So I've now got M2 that has 4 entries in it, but M still has 3.
What would happen if you tried to redef M? with the new.
I can read FM. I can change it, but well, let's just do that. I mean, let me do a simpler one. Let's just do strings here. Let's say def A is string. So I've got A as string. Now I'm going to define B as A. So B is also string. So if I try to redef A to new thing, so my A is now a new thing, but my B is still going to be string. So I'm pointing, so the variables are really just pointers to the original memory location where you set that thing up. That memory allocation that I created there is always going to be there. It's not going to go away. So, and all of these collections are immutable in this sense, or fully persistent. Now this presents a problem if, for instance, you have a very, very large map. So if I have 1,000 map, or 1,000 entry map, and I try an ASOC to it, does that mean I'm going to create a new copy of that map? Well, the answer is no. It's actually done in an efficient way so that you still get a constant time for the addition of keys to a map. And the way it's done is when I create a map, I don't really copy all of the old keys and values to the new location. I just create a new head pointer and point everything to the old one, and then add the new entry to that pointing to that head of the new variable that I defined.
Then aren't you trading off constant lookup time for constant add time? Because now don't you have to do a chained lookup?
It sounds like you just made a linked list, the way you describe that, which makes it slow lookup. It's not really a map.
Yeah, I mean the goal in developing all of these persistent things is for the operations or the O values for all of these things to remain the same. And from what I understand, that has been done. I don't know the details of how that was actually done, but I mean that's my understanding of how the
It's not indexed by something else. Retrieve.
I don't think you can have it both ways.
I actually think there's one of his videos covers this.
Yeah, he
It's
does.
exactly
He does
what,
talk
because
about it.
they bent over backwards to make the performance of this thing. Because when 1.0 came out, it wasn't so performant, and they bent over backwards to improve it. I think it's more storage efficiency.
Let's not
to
forget
look
the
at.
people in the back.
It's check the videos. I know I saw a Hinckley
Yeah,
video
the
covering
exact
it.
data structure he uses is they're called trees, T-R-I-E-S, and I mean he talks about it. I didn't understand all the stuff he was talking about, but the goal is to maintain the same add and remove and lookup order notations that you get with the regular that you would expect for the particular type of data structure, right? So for a vector, I would expect a certain order for an addition of an element to it, and a certain order for the lookup, probably a linear for the lookup, and constant for the add, and those characteristics are maintained within this immutable structure.
Can you free up the space then? Can you undo?
No, you can't. They remain in memory for as long as you. As long as
That's what
you're
namespaces are for. You can toss the old namespace if you need to or something.
I don't know for sure actually.
Well, the garbage collector.
Yeah, the garbage collector will pull stuff out of it. But yeah, I mean you don't know when you're going to. I mean you're always going to have pointers to your newly created stuff, right? You can't get rid of the old.
Well, if you reassigned M in that case, then the old M would
M
be
will go
gone.
away in those cases.
And
Yeah.
so the garbage collector could compact the new M
Correct.
and get rid of the old stuff.
That is true. So I just talked about all the various data structures and talked about how they are persistent or immutable. So another aspect of all of this is that each one of the data structures also implements an interface which makes them seekable, S-E-Q-able. And what that means is there is a certain set of functions that work on anything that is seekable. So for instance, I still have V here right now. So I can do a first on V, and and it will return the first item in V. Rest V will return everything after the first item in V. And then so those operations will work on any kind of collection, anything that implements the seek interface. So first we'll also work on it will return the first value of the string, and the rest will also work. If you're a list person, then these are places for car and cutter, right? Because nobody knows what those mean. And first and rest makes more sense.
Store, but keep
Yeah.
Sorry. So, right, def, car. So, that's what you can do. Now we have that in there. I don't want that. But so yeah, so the seekable interface works on anything, and anything that implements the seek interface can take advantage of all these functions. So, in fact, any iterable, anything in Java that implements the iterable interface will automatically be implementing this seek interface. So I can call this on anything. There are other things like I've listed a few here. Primitive arrays in Java are also seekable. Regular expressions are. So if I'm doing a match on a regular expression, I can get the first match, the second match. I can filter through the matches, that sort of thing. XML instances are also seekable, so I can get the first element or the first node off of an XML instance. Files, IO streams are also seekable. Directories, so if I can get the first file off of the directory. All of these things are seekable, and you can make anything seekable yourself simply by creating an iterator for something. So all of these different seekable functions I've shown you first and rest. There are also these functions called map, filter, and reduce, which I'll show a little bit, demonstrate a little bit later. Now most of these seek interfaces, or the functions that use the seek interface, are what are called lazy, which means that they do not realize the entire list at the time that they are created. So I put a couple of examples here. That's one thing I didn't show you. Let me just quickly do that. There's a function called defn, which lets me define a function. So when I do define a function, I have to give the function a name, and then I create a vector of the parameters that I want to use. I can also, if I want to, put in a doc string x, and then I can do the implementation is the next thing. So you see that I've now defined a function called sqr with a doc string of testing, and it takes about a variable x, or an input parameter x, and then squares it. So now I can call this thing sqr 15. Yay. So, and then I can also run, there's a function called doc that returns the doc string for anything. So sqr, so that will return the parameter list for my function, and also whatever doc string I put in for it. So, so now here I've defined here a function called whole numbers, which takes no parameters, and then the body of the function is to iterate on the increment function starting with 1. So this is in effect the entire set of whole numbers, right? Because iterate, what it does is it takes the function that follows it and continues to apply it over and over and over again. So if I create this function and I try it, it's not going to fill up memory pulling out every single number in the universe. It's going to return immediately. Well, why don't we just do it?
So in Java, the list iterator can be reset, but the regular ones can't be.
The list iterator can be reset.
You can get the front of it again. So in this case, after you've done whole numbers there, and I do next, and I do first, will I get 1 again?
Whole numbers, not the while numbers.
Oh, another thing I didn't show earlier is I can do tab completion for a lot of this stuff too. So any function that I have in here, I can pull out. There's no parameters, so I don't have to put anything in. First whole numbers. It's a function, so I have to call it as a function. Sorry. Oops. No, I screwed it up.
You want to hit Control Metasplat Escape.
There you go.
Too many cooks here.
Control minutes.
I see the weakness already.
So the reason I did that is because I was trying to call it the variable, and it's actually a function. So I do first whole numbers. It will get the first item out of there. I can also do
Rest?
Say again. If I do rest, I can do rest. I'm not going to do rest because another function I can't really call is count because that's gonna
Go ahead and try it.
bring my machine to a screeching halt. But I can do something like these things. I can take, let's take more than that, 20 of whole numbers, and it will return the first 20 of those things. So it is again, it's not realizing the entire list. It's only getting, the first 20 of those things, and in addition, as part of the 1.1 release, the amounts that it pulls down are chunked. So it's not pulling them down one at a time. It's as I use them, it's pulling them down in some size chunks. I'm not sure how it works exactly, but that's one of the new features that you get out of 1.1.
So my point was is that if the function whole numbers were assigned to a variable, and then I called first on it.
Not to a variable, to a function.
Yeah. All you could do is you could get another pointer to the function. All you could assign to the variable would be the first of the result.
So you're saying I can't do a def A to the seek?
I think he's asking is, does whole numbers return an iterator? Like,
Yeah.
could you do a def W function call whole numbers,
There
and then do
is-
first W and get the
So-
first one?
So
Yeah, exactly. Thank you.
So the iterate inc it acts as the accumulator for the list, right? So every time I want to get a new value from the list, I have to call this iterate inc1. So it's you aren't realizing the list until you need it. Right? I don't know. I don't really know how to answer your question.
Or we could just try it.
Try what?
Def W function call whole numbers.
Oh yes.
And then do first or take in whatever of W.
Take 15 again. You're
And then if you
expecting
do
to start
first
at
W,
16.
you're not going to get one.
Yeah, you wouldn't expect it to do that.
You don't need the 15.
15's at 9.
You went first W.
I mean, that's what you'd expect. Right?
Would it?
Depends.
It's still evaluating.
It returns something
First
that's
line.
a proxy for,
Yeah.
and it only gets evaluated when
Now,
necessary.
we were looking at another one of these functional languages, and one of the curious things is the interface between object-oriented and the list-oriented kind of stuff. So, can you do up a non-constant Java object and start calling methods on it?
Oh, you're awesome, because that's exactly where I was going to go next.
Oh, no, thanks for leading.
You are the best. Oh, wait, I was going to do functional programming. Well, I'll do it in your order.
Yeah, no, that's okay.
Instead of doing it in my order. So, let me just go through the Java interop stuff. Because that's fine, I'm in here anyway. So how do I do Java from Clojure is the next question. And the answer is I can do, it's very similar to what you would expect. A lot of the things are the same. If I need to import something, well, first of all, I can do, let's just def new Java util date. So now I have a D, which is a date. And that's if I do a class of that thing, it will return a util date. If I want to, I can.
Yay, date's finally immutable.
Dream on.
Yes, indeed. So if I want to import stuff, I can do it. I have to. Did I show the quote operator we got?
Not yet.
Didn't? Okay. So yeah, let me show you that. So L, I'll define that as. So what I've done here, remember when I said a list gets evaluated, right? So if I try and just type in parenthesis plus 2, it's gonna evaluate that to 4. But let's say I don't want to evaluate that on, I just want the list itself. If I put a quote in front of it, it's going to define it. It's going to return the list itself. So now L is equal to the list rather than the evaluation of that list.
That's from last.
Yes, that's the list thing. So I can eval L, and then that will cause the evaluation to occur, and then it'll be turned into a 4. Now that's what I have to do if I want to import something into. If I run the import statement, so import Java util. Oops. And then I can put in, as many things as I want to, like properties. So now I have those things, and I don't have to namespace qualify them anymore. I can just create D2. Now there's a shorthand for, instead of using new, I can just put in the name of the class and then follow it with a dot. And that's the same as doing new and then the name of the class. So now I have D2. Now I have an immutable D2. Now if I want to, let me just define a property here.
Reference.
Immutable reference.
Yeah. So let me just define a properties object here. Now I've got a properties object. If I want to call a method on that project, on that properties, I can do the dot function, the name of the class that I want to do it. Is that right? Yeah, name of the class, and then the method name, and then the parameters. So that's a method call in Clojure. So now my properties object has a value in it. Now there's another short. That's not a particularly Lisp looking statement. It would be preferable if the method name was the actual function name, because that aligns with Lisp a little better. So there's an alternate way to do this that is preferred, and that is to do a dot method name. So in this case, I'll put dot put is the function I'm calling. Sorry. The name of the object that I'm operating on, and then the values, the parameters to the method.
You can go either way. It's flexible.
You can do it either way. So now my P is there, and this is a perfectly mutable object. You can go in and put on it, and you can change anything in there, but you don't want to do that. If you're going to do that, stop using Clojure. Use something else, because that's not what it's for. You want mutable stuff. And again, with date, if you're going to use dates, which you should in Java, in Clojure, you should use them immutably. You shouldn't go in there and muck around with them once you've created them. So it's not going to. Clojure is going to keep you from doing stuff you shouldn't do, but you should learn the stuff that you shouldn't do, and you shouldn't do it. Right?
There are no side effects.
Yes. So again, when I'm talking about functions, and we'll talk a little bit about side effects in a second, but what we're dealing with here is functional programming. And for those of you who don't know what functional programming is, it involves functions.
As opposed to dysfunctional programming.
Dysfunctional programming.
Most of my
I've been doing my
programming
whole
is
career.
dysfunctional. But so I wanted to run through a little quick exercise in functional programming just as an introduction. And when I pick out a new language, I like to go to Project Euler because it's got lots of neat things. If you're not familiar with Project Euler, you can go to projecteuler.net. There's a series of several hundred now problems, and each problem is a short statement that asks you to do something in your particular programming language, and then you pick a language and you do it. And so I picked completely at random, I picked out problem number 1. And so you can read it. So the problem 1 is if you list all the natural numbers below 10 that are multiples of 3 or 5, we get 3, 5, 6, 9. The sum of these multiples is 23. So the problem statement is find the sum of all the multiples of 3 or 5 below 1,000. Right? So think about that for a little bit and how you would do that in Java. And then we're going to blow your mind and do it in Clojure. No. So, I mean, this sort of problem is in functional programming's wheelhouse. I mean, this is the kind of stuff that you can crank out in functional programming. So it makes a good example. So if I'm in Java, I'm probably going to think about doing for loops and maybe, but I'll let you think about that. I'll do it in Clojure instead. So the first thing that I need when I do this, and this is how functional programming works. You think of the little pieces of the problem that you need to do, and then you compose all of those little pieces into a single big piece that that does the thing that you want to do. So the first thing that I need to do to solve this problem is I need to be able to get a list of numbers. And for that, the range function is what I need. So if I do a range 5, it's going to return to me the list of the numbers between 0 and 4, the 5 digits starting from 0. So if I want to get all the numbers between 0 and 1,000, or below 1,000, I do range 1,000, right? So that's the range function. That's the first thing I need. The next thing I need to be able to do is find the ones that are divisible by specific numbers. So what I've done here is I've defined a divisible by 3 function. Now it's common in lists if you're doing something like this, which is this is called a predicate function, meaning it turns either true or false. It's common in those sorts of functions to end it with a question mark. So I've said divisible by 3 question mark, and it will, and that sort of indicates to me that it's going to either return true or false. It takes a number, and then it does the mod function of my number with 3 and compares it, asks if it's equal to 0. If it is, it returns true. If it's not, it returns false. So I can do a divisible by 3, and I can do a divisible by 5, or if I want to generalize it, which I do, I will just create a divisible by function that takes 2 parameters, the first one being the thing that it should be divisible by, and the second one being the number. So I've simple refactoring there to produce one function out of 2. And I could do further things there in terms of making it simpler, but this illustrates what I'm trying to do. So now I've got something that can get 1,000 numbers, and I've got something that can decide if any one of those numbers is divisible by either 3 or 5 or anything that I want, as long as I supply it with an n. So the next thing I need is something that will go through that entire list and pick out the ones that are divisible by 3 and that are divisible by 5. The function I need for that is called filter. That function goes through a list or a sequence, and the function takes a predicate function. In my example, I'm doing filter. The predicate function I'm using is even question mark, which returns true if the number is even and false otherwise. So if I do a filter of even on the range 5, it's going to return a list of all of the items in range 5 that return true for the even function. So now if I want to plug in my 2 primitive functions, I'm starting to compose a larger function here. So what I'm doing a filter, and then I'm doing this special format here, this hash mark parentheses that you see. That is a way that in Clojure that you create an anonymous function. So the hash mark indicates that this is the start of my anonymous function, and I am calling the divisible by function that I created earlier, passing in 3, and then the percent sign is the stand-in for the item that comes out of the sequence. So this filter will run through every single item in that thing, and then we'll plug that item into where that percent sign is and call that function divisible by with the value 3. So this function will return every number between 0 and 999 that's divisible by 3. Make sense?
Hey, Robert, just like our underscores,
You think?
Percent thing.
Yeah, the percent.
Yeah,
He's
it's
comparing the
similar.
percent to the mysterious underbar in Scala.
And if you have more than one parameter, you do %1, %2, and that sort of thing.
So that, in that sense, it's not like the other one.
Yeah, okay. Oh, I was going to ask you, but the problem was to go 3 or 5.
Right. So now
Stan, what
now
now?
I need the blue. Yeah, you're just right on. You're doing well. So so I'm almost there. I need 3 and 5. So in this case, I need an OR function, which I have conveniently enough in Clojure. So my anonymous function has now grown from 1 line into 3. So I'm doing an OR divisible by 3 and divisible by 5. So now this thing will return 0, 3, 5, 6, 9 as I expect. These are all the numbers that I need to add up. Right. So I'm almost there. I need one more function. There's another function called reduce. So what reduce does is it's complicated. It will take a function and it will apply that function to the first 2 elements in the sequence. Then it'll take the answer to that function and apply the function to that plus the next item in the function, and on and on and on until it gets to the end. So if I supply it with the plus function, what it's going to do, it's going to add up the first 2. It's going to take the sum of that and add it to the 3rd one, and it's take the sum of that and add it to the 4th one. So in the end, I'll end up with the sum of all of the terms. Right. So I think I'm all the way there.
Why can't you just do a simple add? Or
What
does
was that
add take
question?
more
Because
than
he
2?
showed us way back at the beginning, there were
No,
plus and
Dan,
this.
Dan, I didn't hear your question.
This question is why can't I just do a plus,
yeah.
on the? That's a good question.
You should be able
Well,
to.
you could apply plus to the list,
Yeah.
Yeah, you could apply
Right.
plus to the range.
You wanted to show you.
which you haven't shown apply. So.
Right. Yeah, that's true. Yeah, I don't know. That's probably possible. But reduce is so much cooler.
Yeah, all these things. That's old school functional programming. Right?
So here we are.
Reduce,
This
filter,
is PE1. This is or at least my version of PE1. I think there may be others, but so you can see it's 1, 2, 3, 4, 5, 6 lines.
How
And
about instead of having 2 anonymous functions, just one that takes a list?
I only have one anonymous function. It has 2.
Divisible by.
Sorry.
Divisible by.
Yeah, what I'm saying is that
Add a function
the
that-
anonymous function is defined by the hash and then the open and
Right.
closed paren. So this entire thing is my anonymous function.
Yeah, about it. But you
Right.
have a function that would take 3 and 5 and whatever.
Yeah, there's many ways I could do it. I think this is fairly clear as to what it's doing. Now, one of the things that you'll notice about this, and this is common in Lisps, is that it tends to read backwards. Right, I tend to start at the bottom. I'm going to take a range of 1,000. I'm going to apply this divisible by 3 and 5, or divisible by 5 again. I'm going to filter that list, and then I'm going to reduce it with plus. So it tends to read, from the inside out. And there are ways that you can. I mean, if that doesn't work for the particular problem you're working on, or if you want to make it clearer, there are ways to rearrange that by using macros that we might get to later, assuming we have enough time. But
Do you
But-
have the Java implementation just for fun?
I did not do the job implementation. But I'm not talking about Java.
So say this doesn't return 0, right? But it's wrong. You know it's wrong. How would you go about debugging this? It'd be very
That
different
is a
than
good
debugging
question.
the iterable version you'd be used to.
Yeah, that's one of the problems that I have, and this may be my lack of Lisp knowledge rearing its head. But it's rather difficult to figure out if something isn't working. At least for me, it's been rather difficult to figure out why, because you don't. I mean,
Well,
we're
I
not
think
iterating over stuff, right?
You break it apart like you started, right?
Right. Yeah.
And you go to the listener, the REPL, and
And you
take each
decompose.
chunk
You
and-
decompose it. Yeah. You
decompose
sit
it,
there and you
right.
decompose the thing, and you make sure that each individual function is doing what it should be doing. And the reason you can do that is because these functions are all pure functions. That's my next point. So that was a good lead in there. So each one of these functions, because it is pure, and we'll talk about what the definition of pure is, but it can be pulled out in isolation and run by itself, and in other words, decomposed. And so I can look at the individual results of any one of these things and figure out if it's working properly or not. And then, assuming that everything works all right, then I should be able to put them all together and make sure everything works. But again, I mean,
But today the tools don't help you do that. You would be the one
Maybe
It's
they
kinda like
do.
there's no
I mean,
stepping
maybe I
through
just
the
maybe I
evaluation.
just haven't figured it
Yeah.
out yet.
Possible.
No, I think you might be almost there, but what about concurrency? 'Cause that's kind of the deep.
Concurrency, yeah, I'm getting there.
Almost there.
I'm almost there. Yeah, you're a little bit ahead of me, but not too far.
I was wondering, so if you use an IDE like Gips or whatever, and you try to debug, I mean, ultimately it's Java code?
Yeah, yeah. So yeah, I mean, you can run a debugger against it if you want to. Now it may jump into Java code because some of Clojure is implemented in Java,
Yeah.
and they may not be.
There
Java.
might be bugs in
Right. So you have the opportunity to use any of the Java tools that you're used to. You can profile it with a Java profiler. There's nothing keeping you from doing that.
If you put logging statements
The bug
in,
statements
make it
refer to
impure.
The Clojure
Uh-huh.
file.
It's a good question.
So when it says stop, you'll jump into a Clojure file.
What happens when you call put on your
Yeah.
like jump into Java libraries?
You don't debug into Java libraries, you debug outside of Java libraries.
You pull in the source and clips, you
I
debug
do.
right
Oh,
into.
okay, you can jump into Java libraries. So you're saying you
The
want to
number of
jump
times
into
I've
Java
hit equal
libraries.
on evaluating a statement.
I think it's my impression. And again, I'm not, as a non-Lisp person. It's my impression that you don't. I mean, you just don't develop in the same sort of ways. You do this decomposition, composition stuff,
And maybe put traces on functions so you can
Yeah.
see what goes in and what comes out.
and you can certainly log things too.
Throwing away the results of what you expect, yeah.
Yeah.
You write unit tests.
You can actually write unit tests too. I mean, there are built-in ways that you can add tests to a particular function, so that you can make sure that you can run the test. Like I can do a run test against a particular function, and it will run the function that I've attached to it. That's called metadata, and we'll get to that in a little bit too. But there are various different kinds of metadata that you can add to things, to functions, and one of those is a test function.
One thing that might answer some of these questions is how easy is it to, or just part of your presentation, is to run Clojure in Java?
Well, I mean, Clojure again is a jar, so I can include it in any one of my classes. I can access the runtime object from any of my classes as well. So I can pass it in a Clojure script. I can pass it in a Clojure statement or a Clojure function. I can just
Probably
pass it
pass
to the
Java
runtime object, and it will
parameters.
evaluate it and return the value to me. So I have access to it, full access to the Clojure runtime from Java. I can also do things like I've seen an example of where someone will listen on a socket on a port, and then if you connect to that port, it will expose a REPL to that port. So I can just log into my application and send functions into it directly. So you can manipulate your program while it's running just via a REPL, which is kind of cool.
It's just a jar. I would think that you could even, make it part of your design.
Exactly, it's just a jar. Now I can also, I've already shown you can call any Java from Clojure as well.
But I guess that was my question, is whether it's relatively easy, it provides the facility to, for a function in Clojure that you obtain from something, whether you put it in quotes or from a file or something, and then pass it, so
Yeah,
and evaluate it as a big interactor.
right. Yeah, you can do that sort of thing.
But I'm not interested in parsing parentheses and spaces. I'm interested in calling the function written in Clojure. I think that's what he wants to do. He doesn't want to go parse this string and figure it out and then give me back a
Well, where are you
string that
parsing
looks
the
like-
string? All you're doing is you're passing in. If I write a Clojure function, I can throw that thing into my runtime object and evaluate it. I'm not parsing anything there.
No,
Right?
the question is,
No, you're asking the-
how to call it.
You do it in a list.
So someone writes a brilliant list processing function in Clojure. I
Right.
want to call that function. I don't want to write Clojure.
Right.
I want to call that function from my Java.
Oh, I see. Okay, yeah. And this isn't something I was going to talk about, but you can generate class. I can do compiling of Clojure functions into classes.
And then
So I
they'll
can
be
create
available.
class files.
So
class
they
files.
write
Now
the
it doesn't.
algorithm in a cool Lisp-like way and then use it in Java.
Yeah. Now when it creates classes, it doesn't create a single class for say a single script. It basically what it does is it creates a single class for each one of the functions that you create, and then it has some sort of calling or class loading class in it as well that will, so it can be dynamic. You can dynamically add new functions to it, new class files to it. But I haven't done a lot of playing with that, so I can't really speak to it too much. But it is possible to do that sort of thing, and I've seen it done. So this notion of pure functions is something that is pretty important to functional programming in general, and Clojure in particular. A pure function is something that will always return the same value given the same inputs. And the other property of a pure function that it does not have any sort of side effects. It doesn't do anything besides return the value. So, for instance, logging a statement is one commonly example used as this kind of side effect. That's not a particularly horrible side effect to do. I mean, if you have to log, you got to log, but it's not going to hurt anything. But you should. There may be consequences to having side effects. And we'll see some of those when we talk about the concurrency stuff in a bit. But pure functions are good because I always know that I'm gonna get the same thing back when I call this thing. So if I define in Java or something like that, int x equals 3, and then I call on some object the foo method that takes x, then what's x gonna be now? Right? I have absolutely no way of knowing, unless I know what foo does. Foo may change x, it may not change
In that case, x is still 3 no matter what you do.
Yeah.
Unless you said x equals.
Put a date there. Put the damn
Date x, yeah.
But the idea behind a pure function is that I always, once that thing has been set to its value, I always know it's going to be that, even if I'm calling other functions, because those functions don't have side effects. They don't mutate this object or this value, and that's what pure functions give you. They give you that assurance that you're not going to be mucking around with the stuff that you're creating. If I assign that thing to it, it's going to stay there. And if I call that function, it's going to return this thing. And that's one of the constraints that Clojure places on us. And it's constraints that that has benefits to it, right? I mean, you live within that box, and then you get benefits out of that in terms of your knowledge of what your program does. It can't do things behind your back that you don't know about. Hopefully, unless you mutate it in the background, which you can do in Clojure, but you shouldn't do that. So, so that's what that's my introduction to functional programming. Now I sort of jumped ahead with the Java interrupt stuff. So the only things that I didn't show from that was so I showed the method calls. Another thing that you can do is, for instance, static method calls are called with slashes. So I do the class name slash the method, and that will return.
That's kind of funky. That looks a little bit like your user namespace stuff. The notation was.
Yeah, it does. And in fact, it does treat them. So it treats the class as sort of as the namespace to that particular function, which it is. I mean, that's the same sort of abstraction level, right? So the class, and then I could call get property, right?
Oh, that's cool as hell too.
Java class path. So that will return me in my string of my current class path. So that's how you call static.
Can you go down one more level? The classic system/out.println.
Say again?
System/out/println. I mean, it keeps going namespace wise, right? I mean.
Yeah. So it.
That's not a static method on.
Out. Oh, that's a good point. Sorry.
System.exit. I dare you.
Don't.
Yeah.
I can't do everything.
So it would be
Also, another one that I don't use very much, but there's also one that does a chain. So like oftentimes we'll call foo.bar.baz. You can do that in Clojure. Instead of doing it with the chain, you can do a dot dot and then call foo bar chain, and it'll run all of those in sequence for you. I don't have an example of that. Namespaces. So that's I alluded to that earlier. And here I am in the user namespace. I can jump into different namespaces. I think it's so now my command prompt has changed. I've just switched over into a different namespace. So any of the functions that I had just imported, like remember I had M, I no longer have M. So I'm in a different namespace now. So
You can serve namespaces from namespaces? Like, can you get to that M that is a user from foo?
say it again.
Can you access?
When I'm
user
sitting there in
namespace
foo,
from there?
can I
Slash,
ask
slash.
to get M from user? Right? M is laying down in the user namespace. I'm up in foo.
I just lost my slide. Oh, I just blew it all away, so I can't test that anymore.
Yes.
Yeah, I don't have time to do that. Because I want to get to the concurrency stuff. You really need to see that. So in any event, namespaces can be dot delimited in the same way that Java files are. I can store them in directories and refer to them as dotted. I can include other Clojure functions into them, or I can import other Java classes into them. Not much more I can say about namespaces. Metadata is another interesting thing added to Clojure that I don't believe you see in Lisps. So anytime I define a variable or a function or something, there are a certain set of metadata that are attached to it automatically. You already saw a couple of them. For instance, the doc string is one of them. So when I can assign the doc string to that function by well, there's actually a macro that just includes it for me if I put in the quoted string. There is also I can do type hints. So for instance, if I can define a class, or sorry, define a function, and its parameters, if I put this little hash caret thing, I can specify a class that I expect it to be. So in this case, if I'm defining a class methods function that returns the methods of a class, I can tell it explicitly, I want this parameter to be a class, so that and that's mainly to avoid all the reflection that's going on. I mean, there's tons of reflection going on in all of the stuff I've been showing you now, because it has to figure out what is he just added. If you want to get rid of that stuff, you can. There's a global variable that you can set that will tell you, that will warn you when reflection is occurring, so that you can find those places where you're doing reflection, and then you can add these type hints if you want to try and improve the performance. That's sort of a last step sort of thing that you would do in your development, though. I mean, these things are kind of ugly, and if you don't need to use them, then you probably shouldn't. Another metadata piece that was added just in the 1.1 release are these pre and post conditions. So I can, as part of my definition of the function, use this keyword pre and assign it a vector of functions that it will apply to the input parameters before it executes the function. So in this case, I just created a stupid one that asks that the x that you enter be positive. So if it fails, it will throw an assertion exception and it will not execute the function. And you can also do post conditions as well. I can test the value that's being returned, which is replaced by this %sign again. And it will test to make sure that it meets that condition, and if it does not, it will throw an assertion exception instead of returning the value.
So pre and post are just kind of well-defined names. You can put any properties there, basically.
Yeah, well, there are two different kinds of metadata. There's the reader macro metadata, which are these things that you get automatically. So
Right,
pre
yeah,
and post
DefN does that
are
for you.
defined ahead of time. Doc is another thing that you'll see is the name of the file that the function comes from, the line of the file that it comes from. the parameters
But
that
they're
it
just
takes.
property lists on the symbol, right?
What happened to the hash up arrow on that?
Hash up.
Your example. Back to the syntax you just said. Why doesn't it say hash up, curly brace, colon pre?
So that's the way that I specify the metadata. So I do this hash up arrow, and then I put in my map of all of the parameters.
Oh, and that's
that I'm
actually that some ID called doc, and here's the documentation. We're actually in the pre case. You're just giving it a list or whatever the curly brace.
Yeah,
defines,
that may be a mistype on my part.
Isn't def n just a shortcut? For
Yeah, def
with a
n.
bunch
Yeah, I
of
think
other
the fact that
stuff?
it's a def n, I think makes the
Right.
difference.
It does that stuff for you.
Right.
And if you looked at you do a def n of SQR, and then you look at the property list of SQR, you'll see all that stuff on there.
Right.
Or
I
you
can-
could do
I
it
was
by
actually
hand with
trying
just
to do
def.
that here. I forgot my. Here. Oh, no. Fourth time is a charm.
So we look also what the argument
There we go. So this is the metadata that's associated with the plus function. So it tells me what namespace it is, and these are the ones that you get automatically for everything that you define. Now you can assign arbitrary metadata to things too. That's a different function though, and that's a separate map that gets included with the function. But you can see all of the various. Oh, there's a new one that I hadn't seen before. The inline arities one I hadn't seen before. So that tells me how many different types of parameter lists I can have, I think. So I can see the representation of it, the doc string, the name of the function, the namespace, and what file it comes from, and what line of that file it comes from. So again, I mean, metadata is there. Not much more I can say about it. Multi-methods. This is how Clojure does polymorphism. So I have an example of this that I can show. So I've actually got two different versions of the same function, and I'm calling it parting. And this parting has takes a string, and one of the things that this illustrates is the idea of multiple arities. Right, so I have three different ways I can call this parting function. I can call it with 0 parameters, 1 parameter, or 2 parameters. And if I call it with 0, it just calls itself with 1 parameter. If I call it with 1 parameter, then it just calls itself with 2 parameters, the default values. So I put that in there so you can see that you can define your function with more than one method signature. But it's only by arity. It's only by number of arguments. It's not by types. So when I do this, I'm just running this thing through a conditional statement, which is tests the value of the language parameter. If it's en, it pumps out the goodbye in English, es Spanish, and then de German. If it's not, if none of those applies, then I can use this else structure to throw in a legal argument exception with this particular string. So now again, I'm just calling the throw function, which does what you would expect it to do in Java. I'm creating an illegal argument exception object, and then I'm supplying it with this parameter, the string.
But
So-
attaching a precondition would be more elegant, right?
Sorry?
But you could instead attach a precondition metadata.
Right.
More elegant.
Sure. So if I want to add a new language, of course, I just have to go in here and add a new line to it, and go crazy. But I have to alter this particular function, and if it's a really complicated function, then it may not be easy to figure out, well, where do I put this thing? So that there can be issues there if you have to do that. So that's what sort of multi-methods are designed to deal with. So a multi-method is I'm defining with this def multi function, I'm defining a function called multi-parting, and then I'm giving it a dispatch function as its parameter. So I'm saying whenever you see this multi-parting, then you run this dispatch function against the parameters. So I've defined my dispatch function up here to take 2 parameters, a language and a name, and I could have done the same arity thing that I did before, but I didn't for purposes of being short here. And what I'm doing with this dispatch function is just simple. I'm returning the whatever you put in as the language. I'm calling the identity function on language. So it's going to, if I pass in en as a string, it's just going to return en. So next, what I do is I have to define a method for each one of the values that I expect dispatch function to return. So I've created one that takes en. So if this dispatch function returns en, it's going to run this one. And it's going to take the parameters, the 2 parameters. Now I don't care about the language parameter. I already know what that is. So I have the ability to ignore it by just putting it as an underscore. And but I do want to use the name thing because I need to construct my string with name. So in this case, each one of these def methods is a separate function. It lives apart. So I can put this in other files. I can put it in other namespaces. Anything, as long as I can call it, then it will dispatch properly. As long as it can get to the dispatch function, it will dispatch properly. And of course, there's also a default multiparty that it will use in the cases where it can't find one. I can also do things like define an order of precedence sort of thing. So if the dispatch function matches more than one, I have a way to say this one wins and this one loses, which I didn't illustrate here. That's what multi.
So I got a little lost here. This is just a second way to do what you had already done with the arity?
It's not. No, the arity was separate. I mean, I was worried that was going to be confusing. But the difference here is that in this case, I'm using a long conditional statement, which is the equivalent of sort of a switch statement in Java, which can be messy if you need to add stuff to it. What multi-methods do for you is they allow you to separate these things all out into separate things. Now, you'll often see these multi-methods used for class dispatch. So, for instance, if I have something that takes a stream, or I have something that takes a reader, then an output stream or a reader, then I can have a dispatch on that. So if I call the class function on the input parameter, then it will return the class of that thing. And so I can put that. I can create one for output streams. I can create one for writers, or for any kind of thing. Or another common example is strings versus files, right? So if you enter a string, then I expect it to be a file name. I have to create the file first, and then I do the thing. Or if it's a file, then I just do the thing directly. So that's a very common use that you'll see from multi-methods.
So for that example, you're saying you were matching it on the actual string. You're calling to get the class name and then dispatching on that string.
No, you're dispatching on the class name, because remember, a class name is a primitive symbol in Clojure. So if I call class on a string, it's going to return java.lang.string, and I can match against that.
Okay, but you're not going to match against you're not going to get the type hierarchy. You're just getting the actual string.
Yes, you are getting. So you're not getting the type hierarchy.
Yes,
That's a good point.
So it's not really a type dispatch like we would think of from an inheritance hierarchy.
Correct. That's true.
You're just kind of doing.
Now I can call things like isa. There's an isa function, isa question mark, which will go against interfaces. So if I want to test to see if it's implementing some interface, I can say isa interface
So you can
name.
write an arbitrarily complex dispatch function to do that.
Exactly right. Yeah, I can literally dispatch on anything I can think of. So in a way, it's much more flexible than the kind of dispatching that you can do in Java. Another thing that I can do is I can define relationships between parent-child relationships between things inside that are outside of the class hierarchy. So if I want to say that this particular thing is a kind of that, and this is a parent of that, then I can use that class hierarchy as part of my dispatching and do things in that way as well. So it's very flexible. It's really a neat feature of Clojure.
Question.
Yes.
What would be a killer feature that would cause Clojure versus, let's say, Scala?
All right. We're now leading into my next discussion. You guys were just way on to it. Well, at least, of course, that's a matter of opinion, right? But I think what most people would say in answer to that question is the concurrency stuff that that Clojure gives you are the real, where all the sizzle is, if you will.
They say that about Scala as well.
Is that right? Well, Clojure's is cool. And I'll show you that.
Wasn't it a transactional
I need some
memory?
more socks.
Say again?
Wasn't it transactional memory that
Yes.
Clojure
Yes.
has in Scala?
Yes.
Oh,
Right. So in in Clojure, you get these four. Of course, you can use any of the concurrency stuff that you already use in Java, right? I've already shown you how to do Java interop, so you can do any of that if you want to. You're perfectly welcome to. Don't involve me because I don't want to. But no, but the what Clojure does is it defines a set of concurrency primitives, vars, atoms, refs, and agents. And we've already seen vars. They are the things that I was. So I just define a var, and that's a thread local variable. It's just going to stay there, and there's really no concurrency stuff. That's immutable, right? So I can't change it. That's its level of concurrency, and so it's the thread local value that's for that particular variable. Not interesting at all. So the next thing I want. So there are these things called atoms. I'm going to create an atom. And I create an atom by using the atom function, and I supply it with some value. It can be any value that you want. It can be, I'm using an integer here, but it could be a string, it could be a map or anything. And I'm assigning it to the A. Now if I try and type in A, return that, instead of returning the value now, you'll see it's returning an object representation. So this thing is an atom. If I want to get the actual value from it, of the atom, then I do the deref function A. Did I spell it wrong? Fine. Sorry. So that returns, or the shorthand for that is ampersand A. So when I do that, I'm doing a read off of that atom. So now atoms are designed to be mutable, so I should be able to change that value in there. The way you change a value of an atom in Clojure, and all of the primitives that I'm going to show you here have a very similar signature for changing or for mutating the value, and that is you call a function. In this case, I'm calling the swap functions with an exclamation point. They tend to do things that do mutable things. They put an exclamation point so that you know what you're doing. Right? So it's not just swap; it's swap. So and I pass it the atom that I want to swap out. I pass it a function. Let's just do add since that's easy. And then let's add then whatever variables or whatever parameters to that function that you add. So when I do that, it's going to, what it's doing, so it looked very simple, right? So now A is now 20. It was 15, now it's 20. But what happened in the background is interesting. It did that in an atomic fashion, right? So I can be sure that that function was passed, that there will be no, it was done in a concurrent manner. So what it does is it's taking the value that it came out, which was 15, it's making note of that. Then it's going to apply the plus function with parameter 5 to that 15, come out with 20. Before it commits that, it checks again to see that it's 15 still. If it's not, it will retry. It will retry every time that it finds something different. So the key to that is that this plus function is a pure function. Because I do not know how many times this function is going to be run, right? It could run, if there's lots of things trying to modify this atom right now, it could run many, many times.
How would you implement a test set?
A test and set.
So basically, I only wanted to add 5 if the value is currently 15.
So when I create a reference, I can, as an optional metadata, I can supply it with a validator function. I can say if this function is not true, then do not do then do not create the can you do that with modifications though? I'm not really sure.
Isn't
actually.
it saying that the function gets run atomically? So you could put an anonymous function in there that would do that
Right,
test.
that's true, that's true.
Right, and it would run atomically.
That's true, that's true.
So
You
is it
could do
plus
that.
5, you put parentheses, define.
Onsite.
Right,
Blah, blah,
so you
blah.
do the hash parentheses thing, or you could pass and create your own function to do that sort of thing. And then, because again, what you're not changing the value. What you're doing is you're applying your function to the value in that atom,
And then moving the result of that back in as the thing
and
that
then
the
committing
atom's
that
hanging on to.
the result of that function to the reference or to the atom. Sorry, references
The
are.
retries go forever. I mean, does that mean it never stops the retry?
Well, the question
I
is
don't
that
think it is.
So if someone else changes it to 6, then it's never going to be 15 again. You're just stuck in an infinite loop.
well, the thing that's weird though is
No, because
No,
it tests
no,
each
no.
time it
Adding
does,
back
right?
to
So
the-
if it
adding
fails,
back to the
it's going to
result.
take another snapshot of that
It's
value.
going to take another. It's going to take
Yeah.
another byte of the train.
Yeah.
It's a compare and swap. It's going to be in a spin loop that tests
Yes,
the thing each
If I
time.
can get in and out, it's good for
not
me.
spin?
Right.
See, the irony though is that the behavior he describes is no different than calling the function synchronized.
If something is contending with it. Yeah. I don't know.
So the
If you're
question
in a
is
potential loop,
is what he said
you
would
can
be
caught
the
pretty
case.
serious.
Well, it's
As opposed to
optimistic
just
blocking.
synchronized call.
It's,
No,
no,
it's-
it's probably
It is an
not
optimistic
synchronous.
block.
It's optimized blocking.
Yeah,
It's optimistic.
Well, that's
So
what
I-
he said, but the same behavior would have come out of just by calling the function under a lock on the object.
The same
Yes,
behavior
but-
would
yeah,
have come out
okay.
with the
Right.
sequence of
Maybe
events.
it does. Maybe they just don't want to tell the Clojure guys that.
Clock before you wrote it.
Yeah.
Yeah, sure. But then you're holding up all the other threads. Right? It's different behavior.
Right. But of course, you know,
Right.
So let me just go through the other primitives too, just so I can show you them.
Yes.
In this case, another primitive is called a ref. I'm just going to define 2 here. So now I've got savings, checking. Again, you dereference them with the ampersand. Now, if I want to change one of the values, I'd use the alter. Now, there are a couple of functions that will do mutation, but I'm just picking out one. They do different things depending on what sort of thing you want to do.
Doesn't have an exclamation.
So again,
Alter?
no, there's a reason for that, but we'll talk about that. So again, I do the name of the ref that I'm doing. I'm going to subtract this time. I'm going to take, let's take money out of savings. I'm going to take $400 out of savings. So now I've got, extra parentheses. So when I try and run this, I'm going to get an error because a ref enforces transactional behavior, right? So in order to do any kind of alteration to a ref, I have to put it inside a doSync function. So that lets me coordinate changes, right? So I have 2 variables that I want to make sure change together. So I'm putting them all within a doSync, and then this is what's using the software transactional memory. So what it uses something called MVCC, multi-version concurrency control. So what it's going to do here inside that sync is it's going to take a snapshot of these 2 variables that it's going to alter. It's going to operate on that snapshot, and then when it's finished, again, it's going to do the compare with the original. If it's different, it's going to retry. So again, this is where the side effects things come in, right? You don't, if you have side effects, then you're going to be doing them multiple times, or you could be doing them multiple times because you don't know how many times necessarily your function is going to get run.
And Clojure has no way of detecting whether you have those side effects. So it's you, the programmer, have to know what's going on inside the methods you pass in.
Yep.
So the swap has the exclamation mark. Is that telling us that's synchronous?
It's telling us that we are mutating outside of a transaction. I've wondered that
Because both
myself.
of those, you're dealing with references, right?
Right.
The other one was an atom.
The other one was an atom. This is a reference. This is a different. This is a different kind of primitive.
Well, and the definition there was that it was non-coordinated, so that seems to apply that you couldn't operate your do sync on
Right.
two atoms. Is that correct, or am I misunderstanding?
I missed the
Like
last
your
part.
do sync, instead of like alter savings, could you have atom A and atom B and have your do sync? Like
You cannot coordinate with atoms.
with atoms, okay.
Yes.
That's the
You can only
atom.
coordinate with reps. Yeah, I believe that's right. I'm not sure. You might be able to coordinate with agents too. So then the other one that
Do you need those two separate instruments?
so the other one that you can deal with is called an agent. And I'm defining an agent as log, and I'm assigning it an empty vector. And then if I want to change an agent, then I call the send. So in this case, I'm doing a send to the log agent of the conjoin function, which will add to a vector. And I'm going to add the string hello. And when I do that, something interesting happened here. You'll see that the object representation for that is still an empty vector. The reason for that is because what I've done is an asynchronous operation, right? So no matter how long that function takes to run, it's going to return immediately. So if I need to do something that I don't care about it's going to run off in its own thread, making that alteration, and then it will return. I can call functions that will block until I get it back. So I can call the await function, and that will return the value when it's finished. But the point here is that this is an asynchronous operation. You're sending off the function to the agent, and it's doing its
There's a way
thing.
to get the answer, or
It's a future.
and that'll wait for it.
Yeah, it's a feature.
Now, can you run first on the agent as you would any other vector? And that's synchronous.
That's synchronous, yes.
Well,
Because
it's
it's just a memory space, and
The add log blocks until the computation is there.
So if you do a CDR on log, where you get the rest of it?
Yeah, the D reference blocks until.
we don't do CDR.
You should. The log is all ready to go. It's got both elements in it. So that's not a problem.
So let me show some examples, because I'm running out of time and I want to show some examples of this. So there's this thing called the barber problem. People heard of this?
Yeah.
Sleeping barber problem, right? So and this is a common concurrency problem. It's on Wikipedia if you want to look it up. The idea is you've got a barber in the barber shop who's got one barber chair, and he's got 3 chairs on the side for people to wait. And so people come in and into the shop, and if there's an empty chair, they sit down. If there are no empty chairs, and they get turned away. If the barber's chair is empty, then the barber pulls a person out of one of the empty chairs, or one of the full chairs, and makes it into an empty chair. So the problem with this is that you've got 2 different things modifying the number of seats, right? So you've got a producer side and a consumer side, and you have to coordinate the changes to those to avoid race conditions. So here's a Clojure implementation of the bar, and again, I didn't write this, so I can't take any credit for it, but it was such a clear example, I thought, of Clojure doing something that's fairly complicated in a way that was kind of neat, so I pulled it out as an example. So what it's doing is I'm defining a ref of empty seats, setting it to 3, which is the number of empty seats that I want to start with. And then I'm creating an agent that's the barber, and I'm setting that equal to a value of the number of person whose hair he has cut. So it starts out at 0. So it's essentially a tally of the number of people I've cut hair for. And then he also defines just a simple debug function that will take a message and then the number of the customer. So and it's just formatting output. So you'll see that if I run it. So there are two different things that you have to do, and so I've defined two different or I shouldn't say I have because I didn't do this, but there are two different functions that are defined. One is the cut hair function, and the other is the enter the shop function. Those are the two things that happen in the barber mode. So the cut hair function, what it does is it takes the tally, the number of people, the value of that atom, the agent that the barber is storing the tally, and then the customer number. So what it's going to do is within a sync operation, it's going to commute, which is another form of mutating of a reference. I used alter earlier, but commute is another function that does the same thing. It commutes the empty seats reference with the increment function. So it's going to increase the number of empty seats. And then it prints out a debug statement. It does a thread sleep for a random amount of time so that you can do the cutting of the hair. And then after that random amount of time, it prints another debug statement saying that the hair was cut. And then it increments the tally, returns the value of the increment to tally. The number that I send in gets returned incremented by 1. So that function is something that I can send to the barber agent, right? So if I send this cut hair function to barber, then it will run this thing. It will return the new value of tally, which is incremented by 1. The other function is called enter the shop, and that's what the customer does. And this takes a customer number. It prints out the number of the customer that's entering the shop, and then then it runs this when not. So if this is not the case, this thing here, then it will. And the thing that it's testing within a transaction, within a do sync, it tests to see whether empty seats is positive. If it is, then it's going to alter the empty seats by decrementing it's going to decrement the empty seat, and then it's going to send off the barber agent to the cut hair, it's going to send off the cut hair function to the barber agent with the customer number. All of this within a transaction. So I know that these two things are going to be done in the same transaction. Now, if this case is not true, if the empty seats is not positive, then it's just going to print this debug statement saying I'm going to turn away the customer. Wow, so that's wild, right?
Stan, just to be clear, you're saying that the send off will occur in the same transaction, or that the actual hair cutting will occur in the same transaction? Like, is the
The send off will
send?
be part of once it's sent off, then I know the function is going to run. So it's within that transaction. Now it will occur asynchronously. It's going to run off in its own thread.
So the transaction's finished at the point that it's dispatched.
Right. Correct. So then the only thing remaining is just the plumbing of setting it all up. I'm running this do seek operation, which is a sort of a looping kind of thing. It will assign a customer to a range between 1 and 20. So it's going to say the first time customer is equal to 1. It's going to wait a random amount of time, and then it's going to create a feature where it's going to call the enter the shop function with that particular customer number. So this function gets called 20 times. And then future makes it go off in a different thread. So it can just go through, cycle through these all. And,
it doesn't repeat?
The send off
it does repeat.
Is a queuing kind of thing where it only does one cut hair on one barber.
It sends it off asynchronously, so it's going to queue up. Yeah, it's going to queue up.
They're queued up though. It's not all of a sudden the barber's got another cut hair thread going. Oh wait, now the barber's got another cut hair thread
Right.
going.
Correct.
That means that's not a model of a barber shop. I can only cut one hair at a time. Barber.
It doesn't do that.
So send off must be a queue of calls to cut hair, only one cut hairs at a time. Cut hair at a time.
Yeah, I'm a little lost right there too. What
Yeah.
exactly happens after? I can see where the empty seats go down, right? In a transaction, the guy comes in, the empty seats go down by 1, and then somehow send off alerts the barber. There's something to be dealt with.
Yeah, send
But
off.
what if the barber's already dealing with something? Where does that
an
layer
assumption
out?
of the availability of the barber.
Yeah,
I think it's because the
well,
barber's an agent.
I think you're right. I think you're right.
It's got a queue.
It's just not obvious to me how that works.
Yeah, it must be a queue on the inputs of the effort calling agent.
It eventually wakes up, does the next
Calling methods.
Yeah, I'm not sure how that gets done. I mean, I know it does get dealt with, but I'm not sure what the mechanism for that is.
Let's see how many customers walk out the door.
Does it do purely?
Oops, oh no, wait. I didn't show my. Oh, I'll run it again here. So in the
12, 13, 14, 17. That's pretty super.
so in the bottom pane is the output for this thing, right?
Oh, so we did turn a bunch of.
It does them in what random order?
Because it used random time.
Yeah,
Yeah.
yeah.
Oh yes, yes, I see.
So it started out with 1 here.
Sweet.
So 1 entered the shop, 1 got his hair cut, 2 entered, 1 was done, and then it goes on. So it looks like I haven't turned anyone away yet.
So
here's
customer 7 got turned away.
7. Oh, sorry, 7 got turned away. Looks like 9 got turned away. That looks like I got 11 people. Now, yeah, again, I'm not sure how it does the queuing stuff with the agent.
It must be the function of being an agent that does it.
Yeah, it has to be something like that.
Could you go back to the code? I was curious what on the send off and the syntax to the haircut. So the send offs, you pass up the agent, and then you pass up the function. How does the barber become the tally?
Remember, the barber is storing a number, which is the tally.
Right, but I mean, just from a syntactic perspective.
Right. It's let's sort of switch it around.
Okay.
Right? So the agent expects that the first parameter is going to be the agent that you're delivering it to. Right, does that make sense? So cut hair is going to take barber as its first element, as its first parameter, and then customer is the second one. So that's what you get: tally and customer. So tally is the agent, and then it returns another number. So that the tally gets incremented by 1.
Intelligence good, right?
It's something right there.
It's something you can increment because it's got a content of a 0, which is ignorant.
Yeah, I'm still trying to figure out. Let me just go ahead and show my other one here.
Yeah, somehow it's the synchronization between the two sync.
So the other demonstration I had was just of agents, and this one shows a little more Java interop. So I thought it was a good example. And again, this is one I stole from elsewhere. In this case, I'm importing a bunch of exceptions and then a couple of things from the .NET library. Java.NET, sorry. And what this thing is, it's a net sweeper. It's going to sweep the network, look for a particular port. So I've got a function here called host.up. Takes a host name, IP address, a timeout value in milliseconds and a port. So what it does is it uses this let, which is a binding operation. It will take an even number of items vector. So what it's doing is it's assigning this sock address variable to a new Java inet socket address object created with hostname and port. So I've just created a new object, assigned it to sock address. Within that, I'm going to try, in the same sense as a Java try, a with open function. Now, what a with open does is it's what's called a macro. What it does is it takes an object. In this case, I'm creating a new socket object. I'm assigning it to the variable sock, and it will ensure that the close method on that object is run as part of its operation. So I can run that on anything that has a close method, SQL connection or any kind of file stream or anything like that. It will, instead of me having to type in all the close methods and handling it that way, the with open macro does that for me.
This is as opposed to doing a final block.
It handles that. I don't even see it on there. I don't have to type it. Nice. That's what macros are. which I don't think I'll get time to talk about in some of the portions. I'm calling the connect method on that socket object with that particular address and timeout. If it returns something, it will. If something comes back, it's going to return the host name, and if not, then it's probably going to throw in some sort of exception. So I've got a set of catch catch function calls that make it return false. So if I get an IO exception while in the process, it's going to return false. I don't have to do. There are no checked exceptions in Clojure, so I don't have to do these things. But in this case, I want to be able to cache them because that's a condition that I affirmatively want to find. So if that particular port is not open, then I want it to return false. So now I have a convenient function also that takes, it's just calling my host up function with a particular set of parameters. In this case, I want to check the SSH port for 2 seconds. So it's just convenience that lets me call that. IP list is a function that returns a range. Now this thing here is called a list comprehension. So what it does is it's going to take a string and it's going to construct a string made up of the network and a variable of x. And x is a range of numbers between 1 and 255. So it's going to create a whole entire list of IP addresses between 1 and 255. Now I've got 2 versions that call this. One is a single-threaded and another one that's multi-threaded. The single-threaded one takes a network, which is just the beginning of the IP address. And then it runs this doSeek function again. And I'm assigning a host variable to a filter function that uses the predicate function SSH host up, tests that for every one of those members of the IP list network. If it returns true, if that SSH host up function returns true, it will add that to the resulting sequence that is assigned to the variable host. Ooh, that was a mouthful. And then afterwards, it will print out the name of the host. So if the host is up, it's going to print out which host is up. If the host is not up, it's not going to print. It's just going to move on to the next one. So the problem with this single-threaded, and I'm not going to run single-threaded because it takes about 10 minutes, because it's running through 255 IP addresses, and it's taking 2 seconds at least, at the most, for each one of them. So of course, it's going to take forever. Now the multi-threaded one is only slightly different. What it does is, again, I'm creating a let, and I'm assigning to the agent's variable another list comprehension over this IP list network, and I'm creating an agent for each one of the IP addresses. So each one of these things, I'm creating 255 agents, and I am assigning an IP address value to each one of them. And then within this sequence, or this doSeek, I assign an SSH state variable to one of the agents, to each one of the 255 agents in turn. And then I send off that agent, the SSH state agent, with the SSH host up function. So now I'm going to send off 255 things at once, or maybe not at once. It'll go into a thread pool, and it'll do things in the background for me without having to worry about it. And then I will apply the await function to each one of these agents. So that will say await makes it wait until the function completes. So if I apply that await to every single one of the agents, then it will wait for all of them to run, and then I will run a doSeek against a deref of all of the agents, and it will return the values where the host is up.
Do you have any control over the thread pool? If there's a thread pool?
You probably do via regular Java methods or things you do, but I've never played with that, so I don't know.
Would it be easy to rewrite this function so that there's only 10 agents active at the same time?
Yeah, I don't know for sure how hard it would be or not.
Set of steps.
There's got to be create time startup for 255 of those things.
So now I've just loaded that in. I'm not actually running anything. I've just loaded all the functions. I can now call it, and you'll notice my tab completion works with that. And I need to know what my can't read that. Yeah, I hope this isn't a problem.
Yeah.
So I got what? 192, 168, 0.
66066.
Yep. Only one is open, and that's probably me. So I just checked 200. I checked the entire network for open SSH ports, and there's only one open. So you're pretty secure.
No, it just means we're not running SSH.
This is right.
Right, tell that.
Yes. No, I won't go. I won't go there. But so that's I'm running out of time, so I can't really talk about macros. But macros are cool. Macros let you control the language at the syntactic level in ways that you can only do through code generation in Java. Like the stuff that my IDE does for me, like when I click the thing and say add imports, or if I click the thing and say implement these methods, and it will automatically type in all that stuff for me. Macros let me do that without having to do that. Right? So, for instance, I can. You already saw this with open thing. The with open keeps me from having to remember to enter the stupid close function each time, because it handles that for me. I don't even see it anymore. Another really nice one is this do to macro, which takes, and there's a lot of cases where you'll create an object foo, and then you'll do foo dot this, foo dot that, foo dot that. You're doing it like 15 times when you modifying this
So you
thing.
clean up a smell in your code.
Right, exactly. Any places where you see like this thing is
No,
repeated.
it's still a smell. When you have an object that you beat on, you usually should
But you
go
don't
and
see
get
it
the other
anymore. That's the
object,
thing.
have
It goes away. You don't see it in your code anymore. That's the nice thing about macros. Exactly. No, you don't even see the lump. It's not there anymore. But what these things do is they make your code much more compact, and as a result, Lisp languages are very compact. I mean, you can do a ton of stuff in one page of code.
It's the same question though, how do you debug that, right? It's the classic, I mean, it's fascinating. Macros were there in C++, and then they went out again because we all hated them, and then now they're back.
Well, the
So great.
macros are different in C++ than they are in Lisp.
Right.
Right?
So,
The macros in C++ are very little more than text
At
substitution.
least you can debug it, right? Because you can see what they've actually.
You can actually run the expand macro in the REPL.
Right, so
Exactly.
Can you see? Yes. Can you see what this is? Right?
Yes. So if for instance, if I have a macro and I want to see what it expands to, I can type the macro expand, and there are levels. I can do macro expand 1, macro expand all, to see what it's actually producing as part of the eval.
The macros have to be a full
Arbitrary bits.
So hopefully I'm interested enough to do some more reading about Clojure. I'll talk a little bit about what's available. There's basically 2 books now, well, 1.5 books, because the second one is just an early release now. Programming Clojure is Stuart Holloway's book. Holloway he wrote a lot of the code in Clojure Core and Clojure Contrib, so he's excellent. His website is also excellent. He does a lot of really great examples on his website. It's a very good introduction to the language. Joy of Clojure has just come out in early release. I have a copy of the early release. Looks like a fantastic book. It looks like it's going to be more along the, whereas Programming Clojure is more about the nuts and bolts of using a language. Joy of Clojure gets more into how you do the language. Like, it's very idiomatic. Like, there's so much stuff that you have to do it, or you don't have to, but you should do it this way, because that's there are traditions around how you write this stuff, and I think it really goes into that. There's a Google group that has the mail list, very active group. I mean, Rich Hickey's on there all the time, answers your questions. His lieutenants are on there too. Chris Hauser is one of his lieutenants. He's the guy that's writing the code for Joy of Clojure. Also excellent, just a fantastic programmer. There's an IRC channel which all these guys are on all day. I don't know what they do in their real lives, but they're all on this thing talking all day. And then I also maintain a delicious group that has Clojure stuff on it too. So if you want to look at it, and my voice is completely gone now, so I can answer a few questions if you want.
All right. Any couple of questions? Go ahead.
Sorry, I went over.
That's okay.
Is this a hobby or do you have any plans of?
Yeah, it's like, I mean, I knew someone would ask that. I mean, for me, it's just a hobby at this point. I mean, I'm still feeling it out to see where it can be used. I mean, there were cases at work where I thought, you know, this might be a good thing to use it for. I mean, I sort of have this theory that there are probably cores of most applications that you write that should be done functionally, and to take advantage of that functional stuff. And then you can layer around the Java stuff that you need to.
Well, that's why we were asking back at the beginning. I want to call those objects directly.
Yeah, and I
Sit down
think
and
there are
parse
ways.
them.
I think there are ways of doing that, and I'd like to explore that. But I haven't really figured out how that works yet. But it's certainly very interesting to think about. And I think learning the language itself is just a valuable thing to do in any event, even if you're not planning to use it.
Concepts. Any other questions?
Stan, do you know whether there's a reason why there is no construct in the language to say that a function's pure? Do you know? Have you seen any theory as to why that choice was made?
I mean, how do you test for that?
But you could declare it, right? I mean, you could see. I mean, it's composed, right? So if you know that this function's pure, then if I compose other ones, it's pure, then pure, and you know when it gets unpure. So
Yeah,
you could do that in a macro if you want. You could add metadata to the function.
But it must have been an easy thought for them. They must have thought that's a bad idea for some reason, right?
Yeah.
You would know that this function was.
I mean, I think again that gets into the sort of idiomatic stuff. I mean, you have to know what the rules are. I mean, it's not going to make you abide by the rules, but you need to know what they are in order to not kill
Yeah,
yourself.
like how do you decorate all the stuff that's already in Java? Right?
Well, but you know, I mean, see, you know that that's not pure, right? I mean,
But,
you would-
but,
you wouldn't
but,
want
but
to
some
assemble
of Java
what's-
would be
It
pure,
might be, but
not all.
you could say what is definitely pure. You couldn't say the things that are questionable.
There's
Maybe
a-
it's pure, maybe it's not.
Yes.
I think it's the main Clojure website, clojure.org. There's 55-minute. I think it's the only video on there. It's not in libtv. It's on the main site. So you committed to 55 minutes, but he gets into this core notion. You build functions without side effects, and you tease out the stuff you want to change.
Yes.
And then he conceptualized how you would want to change it, and he came with that synchronous, asynchronous. What was the other phrase? Coordinated, uncoordinated. So you got 4 choices of how to build your variable data. And so the notion is you build very reliable core pieces, pull out the stuff you want to change, and then have a very explicit model, as opposed to the object method where you got a bunch of objects and you're trying to come in later with mutex, with all your locking mechanisms in an ad hoc fashion. He tried to build it into the language.
Right.
And that's his core concept, I think, why he really pushed this language. Then he made it Lisp-like and all that.
Right. Yeah, the videos definitely you should check out. They're very interesting. He's a very interesting person.
All right. Well, thank you, Stan.